So just wanted to make a quick video on this weird new quantum stuff. So they showed in a lab, they basically deduced it in a lab because if you're familiar with quantum things, then you know that by viewing the quantum world, it changes it down, the waveforms into a single certain event. So you can't watch it happen. If you watch it happen, it ruins it basically. So we got this quantum physics adding a new data point basically in a computer by using a cause and effect flip-flop. And instead of basically what they're doing is they're using superpositioning to say it could go either way and seeing if it goes through A then B or B then A. And in reality what it's doing is it could go through either one first. It's an indefinite causal order. So basically what that means is that it doesn't necessarily need to go through one and then two. It doesn't matter which one it actually goes through first. So basically it's adding a new data point to quantum computing. And another way to look at this is to say that it not only doesn't need to go through A to go through B, but it doesn't need to go through A then B if it goes through B second, because it can go through B then A, but it's still going through B second. Does that make any sense? If it doesn't, it's a tough concept. I've got it all up there, but on my website I'll post a link. But here's this is definitely by the way, it's done by nature.com. If you want to read the original, I've got the original on my website, but you can go read it over there and see a bunch of other interesting stuff. So here's the important part. So these experiments are opening up new opportunities for transmitting information. A causal superposition in the order of signals traveling through two gates means that each can be considered to send through information to the other simultaneously. Crudely speaking, you get two operations for the price of one. This potentially powerful shortcut of information processing and indeterminate causal order lets researchers do things with quantum systems that are otherwise impossible. Although it has long been known that using quantum superpositioning and entanglement could exponentially increase the speed of computation, such tricks have previously been played only with classical causal structures, but simultaneous nature of pathways in a quantum causal superposition offers a further boost in speed that potentially was apparent when such superpositions were first proposed. Quantum theorist Lucien Hardy at the Perimeter Institutes and Chirabella and his co-workers independently suggested that quantum computers operating with an indefinite causal structure might be more powerful than the ones in which causality is fixed. Last year, Bruckner and his co-workers showed that building such shortcuts into an information processing protocol with many gates could give an exponential increase in the efficiency of computation between gates, which could be beneficial for computation. We haven't reached the end of the possible speedups, said Bruckner. Quantum mechanics allows way more. It is not terribly complicated to build the necessary quantum circuit architectures either. You just need quantum switches similar to those Walther has used. This could find application soon, very soon, because they're making a lot of really good advances in this stuff. And it's actually kind of scary too, because we're talking about something that can process instantaneously and so many exponentially higher forms than average computers that are working inside of Newtonian physics. So yeah, anyway, that's what I wanted to say. Thanks.